for Lab 6A. And I'll walk through the starter code and also how the program should behave. But here, it's the standard stuff. You just click on raw to get it, put it into your PyCharm.py file. The things of note here are the use of constants. So here we have, well, we want to avoid using numbers in our program. It's cryptic. No one knows what the numbers mean. So if we have a name for these numbers, that would be nice. And that's what is going on here. So we have a single assignment statement, and we're assigning these numbers into these variables. But because they're named in uppercase like this, it means that's the designation that these variables are meant to be constants, and that is, they should never change. And that doesn't mean you can't change the value. I could set division to 27, but you can do that, but it's understood that if you see variables in uppercase, they're understood to be constants, and you shouldn't change them. Now, in your previous 2G calculator, we had a separate calculation for every function, and there was a lot of duplicate code. So how could we change that? Well, we could have a single calculate function. And if you knew the operation and the two operands, then you could just pass those three to the calculate function and let it do the work. Now, there are some operations that don't need two operands, and so the implementation I'm showing you here could be improved. But in the case of, say, for example, factorial, you only need one number for that operation, the number to be multiplied by itself. So if you pass the number 6 to the factorial function, it gives you the result of 6 times 5 times 4 times 3 times 2 times 1, etc. So you only need one argument to that function. Same with log. That's log 10, by the way. So the display menu function is as you've seen it before. Here's the while loop. So we clear the screen, display the menu, and here is where we're going to validate. That's the other improvement on this. We're validating the incoming data. So 2G did not, well, it did sound the alarm if they entered an invalid option, but it didn't, this is a cleaner way to do it. So you get the operator choice, and if it's an invalid numeric, meaning it's out of range, you have to reject it. Or suppose the user enters letters instead of a number, you have to detect that. So when you attempt to convert the incoming option from the user, they're going to type in 1 through 9, comes in as a string, you attempt to convert it to an int, and if that int conversion fails, then you need to display an error message and then press continue, which will then, you display the error along with press enter to continue, and at that point, this is the continue keyword will force the loop back up to the top. Same here, when you get the operator, you check to see if it's in range. Now, I suppose you could change that 1 and 9 to, if it's less than add or if logic or log, but that's a little awkward. So in this case, we are using the numbers, and if the numbers are out of range or they're not numeric, well, if they're out of range, at this point we know it's numeric because it survived this test. We just need to check if it's in range. And so now we're doing that. And then if they entered 9, you just say goodbye. The break aborts the loop, and there's nothing beyond the loop, so the program will end. And then down here is where you have to, at this point you know the operator is valid. Now you have to get and validate the operators. So you get the two operators. You're going to attempt to convert them to some type, either int or float, you decide. And then if that conversion fails, this is where you capture it. And if the conversion is okay, at this point, you perform the calculation and display the results. So we just call calculate with the 3 operands, and down here you're going to display the result. Press enter to continue, and then it will keep going. So if you look over here, this is how it would look on screen. It's just very similar to what you had before, except that, let's say I enter this, okay, it's going to detect that, press enter to continue. If I enter something out of range, it's going to detect that like before. Now if I prompt for the first number and I give it something like this, it says that's invalid input. Now that could be improved. It's forcing me to restart the whole operation again. At this point, if they entered invalid data, or say they did this and they accidentally typed W, you want to reject that, but it'd be nice if it just prompted again for the number rather than restarting, going back to the main menu and forcing the user to start all over. So that's, you're going to need this for your project. This whole issue of data validation is what it's referred to. You need to make your program bulletproof from mistakes by the user. Those mistakes could either be inadvertent or deliberate. So the user interface has to act as a wall and only allow in sensible data. Anything else needs to be bounced back at the user with an appropriate but not angry error message. All right, I'll leave it at that. More of this will be explained in class. Bye.